Hello everyone, my name is Lau Yuk Lian from the Center for the Promotion of Knowledge and Language Learning, University Malaysia. Today I'm going to present our innovation project titled Smart Korean Pronunciation Analyzer using dynamic time wrapping. This project integrated AI and phonetic science to make pronunciation learning more accurate, inclusive, and data-driven. Pronunciation has always been one of the biggest challenges for language learners. Traditional pronunciation assessment relies mainly on teacher judgment, which can sometimes be subjective, inconsistent, or time consuming. With the rise of AI and text to speech technologies, we now have the opportunity to analyze voice patterns more objectively using acoustic data. However, while AI can pronounce words correctly, it still struggles to capture the natural rhythm and expressiveness of human speech. Therefore, our study aims to explore how AI speech compares to human learners and native speakers in both precision and fluency. Firstly, how closely can AI-generated Korean speech resemble native pronunciation? Second, can learner speech be quantitatively compared to AI and native benchmark? And third, how can these results support better pronunciation teaching? To answer this question, we use a computational technique known as dynamic time wrapping or DTW to analyze and measure speech similarity. Dynamic time wrapping was originally developed for signal processing, but is now widely used in voice recognition and phonetic comparison. We adopted a mixed method design combining quantitative dynamic time wrapping analysis with qualitative spectrogram interpretation. Our participants include 5 native Korean speakers, 5 non-native learners from UMS, and 5 AI text-to-speech engines. All recordings were processed using Audacity software and standardized to the same duration, loudness, and frequency. This ensures that the differences we observe came from pronunciation itself, not from background noise or recognition quality or recording quality. 5 popular online AI voice platforms were tested: TTS Maker, Voice Maker, TTS Free Text from to Speech, and Narrate. Each engine generated the same Korean sentences that were read by the native speakers and learners. This setup allowed us to compare each AI output directly with real human pronunciation. Analysis workflow. Our workflow follow 5 main steps. First, collect and clean all recording. Spell each audio into 3 Korean sentences or segments. Generate the spectrogram plots to visualize frequency and timing. Apply dynamic time wrapping to align the speech signals and calculate similarity. Finally, compute the S value, which represent the level of acoustic alignment. The lower the S level, the closer it is to native pronunciation. In simple terms, dynamic time wrapping compares two speech waves by stretching and aligning them point by point. If a learner pronounce a word slower or with different timing, dynamic time wrapping adjusts the time axis to match it with the native model. When the total distance or S value is small, it means the learner's pronunciation is more similar to the native speaker. This provides a clear numerical way to measure accuracy instead of depending on human ears alone. The findings were fascinating. Out of 15 speech sample, AI reading achieved better alignment with native pronunciation than the human learners. 4 recording shows almost equal performance between AI and learners. This means that current AI speech models are already approaching native-like precision in many cases. However, human learners still show more variation in rhythm, tone, and stress pattern, which are natural aspects of human communication. An AI reading displays smoother rhythm, more consistent frequency patterns, and fewer pauses. Some AI voices, such as Enrique and Voice Maker, sounded nearly identical to native speaker in spectrogram analysis. On the other hand, human learners exhibited vowels reduction and irregular stress pattern typical of non-native pronunciation. Overall, the dynamic time wrapping analysis successfully validated the acoustic precisions of AI speech and highlight its potential as a pronunciation reference model. So what does this mean for language detection? AI should not replace teacher, but it can serve as a valuable assistant. By using dynamic time wrapping analysis, educators can provide students with immediate database feedback on their pronunciation. Learner can visualize where their speech differ from the native patterns and improve accordingly. We propose a hybrid learning model where AI offers precision and instant analysis while teachers provide emotional guidance, cultural context, and motivation. To conclude, our smart Korean pronunciation analyzer demonstrated that AI can now achieve near native pronunciation accuracy through objective acoustic modeling. Yet human expressiveness, our emotion, creativity, and spontaneity remains irreplaceable. This innovation bridge computational phonetics and education, offering measurable, inclusive, and ethical solutions for language learners. In the future, we aim to expand this system into the real-time mobile and web-based feedback tools that can access university language centers and the independent learners worldwide. Okay, thank you very much for listening.